All right, today we are going to complete Unit 6, Lesson 4, which will be our last lesson of this unit. Okay, today we're talking about something that you've probably never heard of before, which is residuals. And then on the back side, we will talk about correlation versus causation, and that you probably have heard of. All right, so let's start with a residual. A residual is simply the difference between the actual plotted point in a scatter plot and then the y value of the line of best fit. And so, how far off from each point is the line of best fit? Okay. And so, what we're going to do is measure the vertical distance from the actual plotted point to the point on the regression line. Okay. So, um, let's take a look at that. Okay. So we're going to look at example number 1, and we're going to find the difference of the point in the line at x equals 2. So I'm going to go on the x-axis here to where I see 2. Okay. I am going to start at the line of best fit, and I'm going to ask myself, where is the plotted point at x equals 2? And the point is right there. Okay. So how do you get from the line of best fit to the point? And I would have to go down 1. So the residual is -1. And that's it. Okay. The residual is -1. Alrighty. Let's look at when x equals 4. When x equals 4, I'm going to go to where the line of best fit crosses x equals 4, and I'm going to see, how do I get to the plotted point? And again, I go down 1. All right, so down 1. At x equals 6, it looks like it's the same thing. I'm going to start at the line of best fit, and I'm going to go down 1. So the residual is -1. Okay. And let me write that over here in my notes. What about in, let's see, where x equals 9? So x equals 9 right here. Okay, the line of best fit is right there. It looks like it's right at 5.5. In this case, how would I get to that ordered pair or plotted point? And I would go up. So because I'm going up, it's going to be a positive value. And then next, I'm going to say, how much am I going up? And it's not quite 1, it's just 1/2. Okay, so up 1/2. Very good. Okay. Um, Now, actually, I'm going to go back to where x equals 6, and I see that there are 2 ordered pairs where x equals 6, and I kind of overlooked that a second ago. So one of those points, I had to go down 1 to get there. Another point, starting at the line of best fit, to get to this other point, I need to go up 1. So because I'm going up, it's going to be positive. And then how much up? And it was just a 1. So, and +1. So I actually have 2 residuals when x equals 6. Alrighty. And then we could find the residuals for any of these ordered pairs. The residual when x equals 3. Well, here's x equals 3. Start on the line of best fit, and how much up am I going? Okay, so I know this represents 3, and then there's a half more, so 3.5. Okay. All right, that's it. When we're looking at a picture, it's just counting from the line of best fit. How much do I go up or down to get to an ordered pair? Okay, um, great. Let's look at a data set. Okay, so my question is, given this table right here, Okay. Which X value has the largest residual? So if I were to create a scatter plot of these points, then I would have all my points plotted, but I wouldn't know what the line of best fit is. So the first thing that I need to do is to figure out what is my line of best fit using my calculator. All right, so step one. So let's pull up our graphing calculator and let's find the line of best fit for this table. Okay, I'm going to move this a little closer. So let's go ahead and turn on my calculator. And I'm actually going to clear the memory. Okay, and now I'm ready to start a fresh problem. So let's revisit those steps that we did the other day. Stat, enter, and we're going to type in our data set. Remember to hit enter after each number. I'm going to go over and type in my y values, 7, 12, and 19. Okay. You can, just like we did before, don't forget to do second mode to leave out of here. You can turn on your diagnostic just to keep into that habit of doing it. Okay. And then we're going to go get the line of best fit. So, 4, go down to calculate and then hit enter. Okay, so here's my line of best fit, and I'm going to write this on my paper. So I get y equals 1.3x plus zero point 0.4. Great. Okay, so now what I'm going to do is place that into y equals on the calculator. So that's a button that I'm going to hit. So y equals is in the upper left-hand corner right here. Okay, and then I wrote the equation on my paper so that I could remember what it is when I go to type it. So 1.3, the X button is right here next to the green one, plus 0.4, okay? And then it says to gather the list of predicted values. So the way that I do that is I need to, in my calculator, hit second graph. And what this is going to do is pull up the table. Okay, so second graph, and here's my table. And then what I'm going to do is notice that here, okay, x equals 1, I want to go here where x equals 1. And then I want to see the original point was at 0, but what is the new point on the line of best fit? And the answer is 1.7. Okay, do the same thing with 4. 4 is at 5.6. Okay, I don't see 8 up there, so what I need to do is to scroll down using the arrow down. I want to go see 8. Okay, there's 8, and I see that the value next to that is 10.8. And now I'm going to scroll down again in the calculator until I get to 15. Okay, great, there's 15. And then that value on the line of best fit is 19.9. Okay, so let me just erase that there. So now I have a list of predicted values. Okay, Now I'm going to find the difference. So when we were doing the graphing method, to find the difference, we counted. Okay, but we're not going to do that this time. We're going to use subtraction. So take this predicted value and subtract it from the original. Okay, so 0 minus 1.7, 7 minus 5.6, 12 minus 10.8, and 19 minus 19.9. And I want you just to take a second and subtract those numbers. Okay, and here's what I get when I subtract. And so we have gathered our list of predicted values, and then we have found the difference of the actual value minus the predicted value. Okay, now what we need to do is to answer the question, which x value has the largest residual? And so what that means is which x value is the furthest away from the line of best fit. Okay, so what I'm going to do is I'm going to find the largest number. Okay, the largest number. Ignoring the plus or minus signs. Remember, the plus sign just means that it is above the line of best fit, and the minus means that it is below the line of best fit. Okay? And so the largest number, if I'm ignoring negative signs, is 1.7. And they wanted to know which x value. So the x value here is 1. Okay? So x equals 1 has the largest residual value. Great. Okay. Now, there were some notes up at the top that I kind of skimmed over. Okay. It says in this note here that the sum of the residuals is always equal to blank. Okay. So what we're going to do is we're going to take these residual values, negative 1.7, positive 1.4, positive 1.2, and negative 0.9. And I want you to use your calculator and add those all up and tell me what you get. Okay. And I'm betting if you finish that problem up in your calculator, you're going to get 0. The sum of the residuals is always equal to 0. Okay, so if you ever want to know if you did your residuals correctly, all you have to do is add them up. If you get 0, then you know that you've done it correctly. If you get something else, then you've made a mistake somewhere. Okay, all right, great job. So that is just the basics of how do I find a residual from a table. What I want to come down here and show you next is what it's going to look like when you take your EOC. Okay. And this is actually an EOC released item. So what it's going to give you is a word problem typically. It'll say a survey was conducted to study the relationship between a student's height and their shoe size. The results of the survey are recorded below. And what they're going to show you is just this table right here with the height and the shoe size. I have given you the rest of what you need to do also in a table format just to help us keep it all organized. Okay. So the very first thing that I'm going to do before I even read this question down here is I'm going to go ahead and find what are the residuals. So again, we will need our graphing calculator to do this. Okay. I'm going to turn it back on and I'm going to clear the memory. Second plus 712. And then I'm going to go ahead and very quickly type in all of my data. So stat edit 68 enter, 66 enter, 75 enter, 71 enter, 67 enter. The enter didn't go through last time. There we go. 65, 67, and 75. So these are the height of different people or students, okay? Next, I'm going to go over to L2 and I'm going to type in their shoe size. 12, 9, 12, 11, 12, 8.5, 9, and 13. Okay, so my L2 and my L1, they have the same number of data in them. I could go make sure that I didn't make any typing errors. And then what I'm going to do is hit Stat, over to Calc, 4, and Enter, all the way down till I get to Calculate. And then Enter one last time. Okay, and now I have my line of best fit. What I'm going to do is write down my line of best fit. Okay, so y equals 0.323x minus 11.559. So I'm rounding this to 3 decimal places. Okay. I am following the steps that I did up here. So step 1 was find my line of best fit with the calculator. Step 2, place the line of best fit into y equals. Okay, so that's where I am now. So let's go to y equals. I'm going to place this in 0.323x minus 11.559. Now I'm going to hit second graph. I'm doing step 3, second graph, and here is my list of predicted values. Now I do want to show you a shortcut because I need to get to a height in my X column of 68. You could scroll down 68 times until you get all the way there, but it is going to be helpful to you to know the shortcut. If you hit second window and then type the number 68 and then go back to second graph, it will jump straight to where x equals 68 for you. So let me write those steps down for you. So, I'm just going to add this here, a shortcut to gather the list of predicted values. We did second window, and then we had to type the x value that we wanted to find, and then we followed that up by hitting again second graph and going back. Okay? All right, so what I'm going to do now is I'm going to gather this list of values. So at 68, I get 10.45. I'm sorry, 405. At 66, let's go up to 66. 9.759. At 75, so let's scroll down. I get 12 point. Okay, at 71, I see 11. Okay, I'm right here at 71. It's 11.374. Okay, at 67, Let's scroll back up to 67. It's 10.082. Move my paper up a little bit. Okay, at 65, it is 9.436. At 67, it is 10.082. And then at 75, it was 12.666. Okay. So what I've done is I used the calculator to gather this list of predicted values. Now what you need to do is, just like in this very last step, D right here, okay, you need to find the difference of the actual values minus the predicted values. So here's what I would do, just to so I don't have to rewrite as much on my paper. I'm going to say 12 minus 10.405 equals what? Okay, so let's subtract all these. And I want you to go ahead and pause this video and do all of that subtraction on your own, and then just come back and check your values with mine. Okay, but it is important that you understand that we are using these same steps down here. Okay, use these 4 steps. Alrighty, so pause your video. All right, welcome back. You should have gotten this list of values here, okay? And we are ready to go on to our last part of this problem, which is the application piece that the EOC will expect us to be able to do, and that is to answer this question. What percent of students have shoe sizes that are more than one size different from the size predicted by the line of best fit? Okay, so we're looking for residuals that are greater than 1. Okay, greater than 1. We are going to ignore the negative signs. Okay, so I'm going to circle them all, the ones that are greater than 1. So 1.5 is greater, 1.9 is greater, 1.082 is greater. Okay, so I have 3 total. Actually, not 3 total, but I have 3 residuals that are greater, okay, or 3 students. They want a percent. So in order to get a percent, we need to divide this 3 students by the total number of students, okay, which is 1, 2, 3, 4, 5, 6, 7. There are 8 students in all. So in our calculator, what we will do is turn this on, second mode, to get out of here. And I'm going to do 3 divided by 8 and hit enter. And I get 0.375. And that translates as a percent to this problem right here. Okay, that is the same value. Okay, and so our answer for this is C. It is C. That is a very big, a lot of work example. There's a lot going on there. There's a lot to understand, okay? Starting with using these 4 steps first. And then once you have the residuals, um, then you do your interpretation second, and then you do this changing it to a percent third. Okay. But step number 1 does take the most amount of time. All right. Great job. Let's lighten it up and make it a little easier for us. Okay. Correlation and causation. This is a little easier than residuals. The correlation between data is what we were already finding when we were looking at scattered plots. I told you to determine if the correlation was positive, negative, or there was none at all. Okay. And that's easy to tell just by looking at something. So if you look at number 1 down below here, I see a picture. And I want you just to very quickly tell me what kind of correlation does this scatter plot have? Okay, so from the left to the right, it is increasing. And when it's increasing, it means that it has a positive correlation. Okay, so that's review of what we did a couple of days ago. But now let's talk about correlation, or I'm sorry, causation. Causation is when one thing causes another thing to happen. Sometimes we think causation is implied, but it's not always, okay? This is something that you have to be able to prove. So please add this to your notes. You have to be able to prove it. Okay. So, um, let's look at number 2. Now, actually, I want to read this problem first. It says a survey of 50 vehicles in each of 10 cities was taken to measure the average noise pollution. Okay, so I'm looking at my graph. Noise pollution is my X variable. So the noise pollution is increasing. Okay, noise is increasing. And then the percentage of vehicles with mufflers on their vehicles. So mufflers is number of cars with mufflers is also increasing. And then the results are shown in this diagram. Okay. So which statement can be concluded about the data? There is causation between the number of vehicles with mufflers and the average noise pollution. Okay. Can we prove that when there is more noise pollution, there are more vehicles with mufflers? There's lots of reasons that people get mufflers. Sometimes, and okay, just in case we don't all know, a muffler is a piece of equipment that you put on your car that helps to minimize noise. That's its purpose, or at least one of them. Um, so minimizing noise. Okay. So some states have rules about mufflers where every single car is required to have one. And I think other states might not have rules. I'm not sure on all of that information, but I know that there are some cars in some places that just don't. Okay. Some people don't like loud cars, so they get mufflers put on for that reason. Some people, if it's some kind of sports car or they want to get a lot of attention, they might leave their muffler off because they want their car to make a lot of noise and attract attention. Um, so when it comes to noise pollution and then more people having mufflers, that is not something that we can prove easily because it doesn't necessarily have to do with noise pollution as to why they're getting the muffler. Okay, so we have to eliminate A because we can't prove it, not based on the data that we're looking at. Okay, let's look at B. There is no correlation between the number of vehicles with mufflers and the average noise pollution. Well, if we look at our answer from number 1, before we knew what we were really doing with the causation, I asked you what type of correlation is it? And you told me it was positive, and it definitely is demonstrating a positive correlation. So that is just simply not true. Yes, there is a correlation. Okay. So not B either. Okay. C, more noise pollution causes people to use more mufflers. That might be true for some places or some people. Like I said, some states have laws where you're required to have a muffler, um, but others don't. So this is sometimes true, um, but not always. Okay, so if it's not always true, that should say always, then we can't say yes to that. Okay, let's look at option D. There is a correlation, but not necessarily causation between the number of vehicles with mufflers and the average noise pollution. Well, we've eliminated all the other options. Okay, we've tried to think about what causations there could be, but we can't say that more people have mufflers because of one of these reasons. It might be something that's kind of broken up where more than one um, causation is true. Okay. So, but we don't know anything else for sure. We can't say that it's one thing that causes people to have mufflers. Okay. All right. And then let's look at number three. David noticed that more mufflers are used because of more noise pollution. This is incorrect for what reason? Okay, so this is kind of similar to number two was. The data shows no correlation, and that is not true because of number one, it has a positive correlation. B, the graph shows that less noise pollution causes fewer mufflers to be used. Okay, and the word causes here, okay, we could not determine that that was the cause. So we have to eliminate that. And then C, there is a correlation, but no causation between the variables. Okay. And that's pretty much the same answer that we chose in D. I just wanted to put both of these questions up here for you so that you can really look at how differently these are worded, even though they get to the same conclusion about the exact same data. All right, and the very last part of our notes for today is to read these five different situations and to decide if these represent um, a correlation and a causation, or if they are just a correlation. Okay, so let's just read these together. Again, causation, you would have to be able to prove that one thing causes another thing to happen. Okay, so the number of cold, snowy days and the amount of hot chocolate sold at a ski resort. Would this be considered correlation? And the answer is yes. Okay. All of them have a correlation. All right. But can you determine causation from this? So, can you prove that because it's cold outside, that is the only reason that the amount of hot chocolate is improving? And the answer to that is no, you cannot prove that. All right. Um, what about the number of miles that you drive and the amount of gas that you use? Well, that's definitely a correlation. Okay. And then, um, does how much you drive your car affect how much gas you use? And the answer to that is absolutely yes. That is a causation. I forgot my I. So that is definitely a causation. There is no doubt about it that the more you drive a car, the more gas that you use. Okay. Number three, the annual salary and the blood pressure for men ages 20 to 60. So, I believe that what they're trying to say here is that there's a correlation between how much money you make, and then blood pressure is when it's too high, it's not healthy for you. Okay? They call high blood pressure the secret killer because there's not a lot to show how that's negatively impacting your body. Um, so, but stress is definitely one thing that could cause high blood pressure. Um, so annual salary, they're not very specific about this. Like, I could take this two different ways. What about a high annual salary? If I make a lot of money, odds are I have a job with a lot of responsibilities and that might cause a lot of stress. So maybe that would cause my blood pressure to increase. Um, Another way to think about this is a low annual salary. What if I work a very low minimum wage job, but I have three kids at home that I'm trying to feed and I don't have enough money to do that? That would also cause me to be stressed out. Um, so then there are some people who make middle of the road money and perhaps they just don't exercise enough or they don't diet well, like meaning they don't make right food choices that are healthy, but they make a medium annual salary. Um, so yes, you could look at a scatter plot and you could probably determine different types of correlations, but there is no way to say that your salary causes high blood pressure. There's way too many other outside factors, okay, with blood pressure. All right, number 4, the number of cars that travel over a busy holiday weekend and the number of accidents that are reported. Okay. There's definitely a correlation here, but is there a causation? Can you say that because there's more people on the road, that there are more accidents that are happening? Um, it would seem likely, but that's not necessarily the reason, right? There could be a very few number of cars on the road over a busy holiday weekend. Like, say it's, I don't know, 11 o'clock at night, and there's not a lot of cars out, but maybe those cars are rushing because they didn't get off of work till 6 o'clock and they're trying to get to grandma's house 4 hours away before Thanksgiving dinner, right? They might just be very high stressed, even though there's not a lot of cars on the road, and maybe they make some bad choices and there's more accidents because of that. So we can't say that the number of cars on the road causes more accidents to happen. It could be the situations or the mindsets of those drivers that are in the cars leading to the accidents. Okay. So we're going to say correlation only. And then finally, the age of a child and his or her shoe size. And I am glad that they said child here. That is the key um, reason that I am able to say yes, correlation, and also causation. Okay. So the age of a child definitely causes their shoe size. Um, are there exceptions to this rule? Absolutely. There are children who perhaps are not developing correctly. Maybe they're growing really, really slowly. Okay. There are different outliers that could be different than the generalized norm, but for pretty much all children. And that's why they are able to size clothes and shoes for children the way they do. 2T/3T. Children generally wear, I think, a size 7 or 8 shoe. Um, or size 9 also, because there's two different years in there. The bigger that a child grows, their body grows proportionally. And we can expect a 2-year-old to be, right above knee length. We can expect a 5-year-old to be a little taller than my hip, right? And so when we have these expected size ranges for children, their bodies grow proportionally, so their shoe sizes will also increase with their age. Of course, until you get to a certain age and then you quit growing, which is why I said child is the key word there that makes that causation. Okay. So hopefully this makes sense. Some of them you really do have to think about. Okay. But that's probably the trickiest part is just thinking about, is that the only thing that could cause that thing to happen, or might there be other factors? Okay. Alrighty. There should be a quizzes posted for you to practice, and then you want to make sure that you are prepared for our quiz. Um, Actually, quiz number 9, we already took it. I'm sorry. Our test is going to be coming up in a couple of days. So you want to be sure that you are doing well in our quizzes and that you're also studying your notes and making sure that they're completed before we take our test number 6. All right. All right. Well, that's it for today.